There's never been a better time to start planning your career's trajectory. With LSU's online engineering programs, you can equip yourself with the skills to move forward in your career. Their degrees are 100% online and designed for working professionals balancing life's responsibilities. LSU Online offers multiple engineering degrees and certificates with focuses in industrial, civil, healthcare, petroleum, and transportation. They also offer affordable flat-rate tuition nationwide. That's just one of the many reasons U.S. News ranks LSU Online as one of the best online programs for a master's in engineering. Visit online.lsu.edu/podcast to learn more and receive a code to waive the application fee.
This is Problem Solved, the IISE podcast, where we talk to industrial and systems engineers about their work, ideas, and solutions.
Hello and welcome to Problem Solved. I'm Keith Albertson, Managing Editor at IISE. Today we're going to delve into one of our favorite topics, space exploration and systems engineering, something we featured previously on the podcast and in IISE magazine. Our guest is Sean Butts. He's a systems engineer and fleet manager for the Gateway Logistics Services Launch and Space Segment Systems at NASA's Kennedy Space Center. He's going to share some details about the Gateway project, which will create a supply chain to the moon to support the Artemis program. The first uncrewed Artemis mission is scheduled to launch in the coming months to test the spacecraft and systems designed to return astronauts to the moon, Mars, and beyond. You can read more about it in the November issue of IISE magazine. Sean, thanks for joining us here today. We're really excited to discuss this project with you. Before we talk about Gateway, tell me a little bit about your background, how you became associated with NASA and this project.
Well, hey, Keith, I really appreciate you having me on the podcast. My background is I started at KSC. My career started at KSC. I went there right out of high school. I started to work with a contractor for the space shuttle. The United Space Alliance was in charge of the operations for the space shuttle about the time I graduated college in 2000. And I actually spent some time doing co-ops at KSC before I went full-time as an engineer. And the way I got to KSC was kind of odd. Like I went to school. I grew up in Maine, northern Maine, way up north. And I didn't have aspirations to do anything particularly spectacular, but I knew I wanted to study aerospace. I was really fascinated by jets and aircraft. I loved the idea of flying. And I just wanted to be involved some way in jets and aircraft. That was kind of a growing passion inside of me. And my parents were both in the Air Force, and I lived right outside an Air Force base. So I'd see B-52s flying outside my bedroom window all the time. And one time in high school, I went to my guidance counselor just to kind of talk about career opportunities. She asked me a little bit what I wanted to do. I talked about engineering. I must have said the word aerospace. And she reached behind her and she pulls out a VHS tape from Embry-Riddle Aeronautical University in Daytona Beach, Florida, which I'd never heard of before. But it turns out that someone from my little town in northern Maine had wanted to be a pilot and went and studied at Embry-Riddle in Daytona Beach. And he was successful down there and had sent back this cassette or this VHS tape. So she loaned that to me. I took it home. I watched it. And, it was a really well-made video. Kind of introduced you to the Daytona Beach campus, palm trees, sunshine, green grass everywhere, showed their engineering buildings and some of the wind tunnels that they had there. And yeah, I was hooked. I said, well, sheesh, this looks like the type of place I want to go. And it was affordable. And that's kind of how I ended up going down to Florida. And then a little bit of the same thing that happened in high school happened in college. I went to my career counseling office in Daytona Beach, and they mentioned that there were co-op positions at the Space Center. Would I like to apply? I couldn't apply fast enough. And no kidding, when I got the response back that I'd been accepted for a co-op position at the Space Center working on space shuttles, I think I actually was in tears a little bit when I cried when I called and talked to my parents about it. So it was kind of an interesting roundabout way of getting down here, but it worked and got me down here, and I've stayed ever since.
Well, it's a dream job for an engineer or anyone who's a space geek, that's for sure. Tell us now, just kind of give us an overview for folks who aren't familiar of the Gateway Logistics Services mission and the role it's going to play in the Artemis program. The Artemis program is the return to the moon and beyond, and Gateway is an important part of being able to supply those missions. Just give us an overview of what the goal of Gateway is as part of this program.
Sure. So if you think about, ask your listeners to imagine they're going on a long car trip, right? So they're going to drive from Florida to California. Now, most of us couldn't make that trip on our own without some sort of help on the way, right? You've got to stop for gas. You've got to stop to get food. You've got to stop, in some cases, to rest if it's a long enough journey. Certainly from Florida to California, you're going to have to sleep sometime. You can't make that journey without infrastructure along the way to support you on your travels. And that's a little bit about the concept of what Gateway represents as far as us trying to get back to the surface of the moon. We've got to figure out how to make fuel, water, food available for the long duration journey to Mars and for the crew who's flying to the moon. And the Gateway represents that outpost, that stepping stone to get to the surface, the place that you're going to aggregate your fuel, your supplies. The crew is going to arrive there and prep their landing systems. We now have a better idea of what the lander is going to look like. It might be a SpaceX Starship by the looks of things. But before we found out about SpaceX getting the award, we thought there might be a more traditional Apollo-like lander. So you've got to aggregate the lander components at the Gateway. The crew gets there. They've got their supplies waiting for them, ready to go. They could pack up the lander, make their descent down to the moon, and they'll have all their supplies will have been brought to them by the logistics team, by the logistics service. And the idea is to take the Gateway idea of stationing everything in orbit around the moon and an easy to get to orbit that's convenient and that's stable, and extend that to the Mars mission too. We're going to work on these concepts for outfitting the crew so they can go do their exploration missions at the moon. We're going to extend that same concept to the Mars missions by either pre-positioning or sending logistics vehicles out there to intersect with them so that everywhere they go in space, they're going to have logistics supplies waiting for them and ready. Because they certainly can't bring everything with them. The idea of building one giant spaceship that can do everything is a little science fiction-y at this point. And it's much more feasible with the systems we have in place today and in the near future to kind of continue the supply chain out ahead of the crewed missions when they go there.
From a planning perspective, the imagination just sort of reels as to how many different logistical aspects there are to a mission of this complexity. What kind of engineering team is working on this at Gateway? Do you have a large team with a lot of different types of specialties? And what are some of the different roles that systems engineers are playing as they prepare for this mission?
Certainly, the Gateway team is a very, very large, very diverse team of engineers and analysts operating out of the Johnson Space Center. They've got some of Johnson's best minds working on the Gateway program, developing concepts for how to build out the station, developing requirement sets for defining how the different parts of the station are all going to work together. And I call the station because in my head it's a space station. Others have referred to it as a spacecraft, but I keep saying station. So someone will probably have to excuse me if they disagree. So the engineering team has a huge task ahead of them in terms of designing the ship and working with all the different contractors and the international partners we have. It's not just a NASA design and developed concept. There's a lot of work to be done between different engineering teams across the globe. We've got international partners in Canada, in Europe, and probably future international partners too as we start to build out and operate the station. At Kennedy, our primary focus is to make this a commercial procurement for Gateway Logistics. KSC has been given the logistics side of the Gateway equation, and we're pursuing providing that logistics service to the Gateway much the same way that commercial companies are supplying the ISS through the Commercial Resupply Services 1 and 2 contracts. The commercial model we're using also is very similar to the commercial crew contracts model. Obviously, we're not flying people to the Gateway, we're just flying the cargo. But these commercial enterprises have been borne out to be very successful, very cost effective to the government. And that's kind of our mantra. We want to buy the right service at the right price. And so KSC's engineering team is predominantly focused on implementing what we call insight and surveillance, or insight and oversight of the contract that we let. So our first contractor has been chosen to be SpaceX. They've proposed a variant of their Dragon cargo module to be used to fly logistics to the gateway. It's the Dragon XL. The XL stands for extra large. It is quite bigger. It has a lot more volume. And the way Kennedy is going to interact with SpaceX as they design and develop that module is to be with them the entire way, following along with the design and development, doing independent analyses, sometimes independent verification of some of the work that SpaceX is doing. And that requires a lot of analysis capabilities. So we're building out that internal IV&V, independent verification and validation team here at KSC today. And we've also got systems engineers working on the tools and processes we're going to use to flow requirements, define requirements for all the different missions we're going to fly. We expect every mission for the Gateway Logistics Services to be slightly different than the one that came before it. We're looking for versatile, flexible logistical solutions. We know we have to fly some big components. We're carrying up the robotics arm, as well as just passive cargo. Occasionally, there will be some science payloads or some payloads to support the crew on the inside of the logistics module. And integrating all those payloads is going to take quite a bit of systems engineering knowledge and know-how, and dealing with a lot of different entities from all over the globe as we deal with different payload developers and the different stakeholders who are going to want to help do science at the gateway, as well as the folks who are responsible for prepping the cargo that we're going to fly for the crew as it gets there, the human spaceflight side of things too. So our team has to grow a little bit. We're a little small at the moment. We've probably got 30 people in general working all of Gateway Logistics. As we ramp up and get fully funded and start supporting more and more Gateway missions, we expect the team to grow accordingly.
And you mentioned just the logistics of sort of maximizing how you get all this payload. You're going to have so many different types of elements, some of them perhaps volatile, pressurized, life support. How difficult and what are the logistic challenges of being able to maximize the space in a limited amount of space in the vehicle that'll be taking it up there? That's got to be quite a logistics challenge to be able to just to get everything you need that far and have it there on time and in good shape.
That's true. And luckily, the challenges that we face by trying to fly different types of cargo, different kinds of cargo, we might be carrying food, medicines, we'll be carrying things like clothing, toiletries, you name it, anything you think you might need on a long road trip. That's exactly the sort of stuff that's going to be in the logistic module. There will definitely be toothbrushes and toothpaste and wipes and all kinds of personal items that might fly, in addition to things like fuel and oxygen and nitrogen. Carrying all that, we are fortunate that we don't have to redesign the whole concepts, right? We leverage a lot of expertise in human spaceflight and low Earth orbit through the way the ISS has kind of evolved. It used to be serviced by the space shuttle, and it also gets serviced by the Russian Progress vehicles. So there's already a lot of background and expertise on what's the right form factor for packing things, what's the right way to quantize things. Is a small bag better or many large bags? I think we've arrived at some pretty common configurations. There's things called the cargo transfer bag, CTB concept that JSC uses for NASA cargo. That we're pretty much adopting that same concept. They come in certain sizes. They have certain features like zippers and pockets and see-through things so the crew can interact with them. They've been developing these cargo baggy type logistical systems for some time now. We're really just taking that and expanding on it. Luckily, SpaceX, our first contractor, has a lot of experience working with those things. So when they saw what sorts of requirements the Gateway Logistics Services requirements were going to be, they recognized immediately a lot of the precursor ISS type stuff. So SpaceX has a lot of experience in how to pack and store things efficiently. We also have relationships with third-party contractors who do a lot of the early packing of the bags. So SpaceX's job is to be the carrier, the transporter. There's other contractors who get involved to make sure that the bags are packed properly. Each bag is the contents of each bag are known and recorded. the bags are tagged and identified. And when they're loaded into the SpaceX vehicles, we know exactly where the location is because SpaceX keeps track of where each bag is going to go, and they share that information with NASA. And then you end up with a cargo map of the inside of the vehicle that's part of the mission package, mission planning and training package, so that the crew, when they're up on orbit and they're opening the module for the first time to go in and start extracting from the cargo vehicle the things that they need on day 1, day 2, or day 10, they've got that manifest and that logistics map in hand so that they know exactly where to go and get it. And in addition to that, some of the lessons learned from ISS, with the ISS being as big as it is, it's common that things get lost. They're losing things all the time, or they know something was put somewhere, but they don't know maybe exactly where in a particular module that item was stored. So
we can all relate to that. Yeah.
Yeah. So anybody with a cluttered closet or garage can definitely relate. So Gateway is working on inventory management systems too, things with RFID tags and readers and antennas that are going to help the crew to identify where, which module something might have been moved into. And in some cases, they might be able to find it to a specific location within a module. They could be integrating this inventory management system into cupboards or stowage areas that are going to be integrated throughout the Gateway. So with things like that, we're hoping to kind of use some of the lessons learned on the ISS and low Earth orbit and extend it out to the Gateway, where crew time is really your scarcest resource. On ISS, crew time is still a luxury to have enough time in the day for the crew to accomplish all the science and all the ISS maintenance that they have to do. But they're there 24/7, right? That's their home in space. With the Gateway is really more of like their Motel 6 in space, if you will, right? They're going to show up. They'll probably have, in the early days, we'll have a really short mission. And the crew's going to be so busy prepping for that lunar sortie, to go to this lunar surface, that we don't want them to be spending a lot of time packing and unpacking and looking for things. So it's really critical that we get this logistics. Where is that thing I need? And is it easy for me to get to down pat? That's a problem that we really need to solve for the Gateway to be successful.
Well, and as you mentioned, the ISS is sort of a comparative type mission, but it's so much larger, relatively speaking. It's also in low Earth orbit. Gateway is going to be orbiting the moon 250,000 miles away, and certainly not with the same amount of cargo space. What extra logistic and just specific challenges are you going to face from having something on an outpost that's that far away and just being able to troubleshoot anything that comes up?
Well, yeah, you've definitely picked one of our biggest challenges. Maintenance is a big deal. Obviously, the ability of the crew to work on the ISS is key. They have multiple ways to do EVAs, and EVAs were a big part of how the ISS was planned to be operated and maintained over its. I won't even claim to know what the original lifespan of the ISS was, but we're pushing 24 years here soon. The Gateway, the idea is that we are less reliant on EVAs for assembly of the Gateway. There's no EVAs that are necessary. An EVA is extravehicular activity where the crew has to put on their spacesuit, go through the airlock, and they're working working and assembling things in space. So the Gateway will have an airlock, but the idea is that all of the modules can be brought up to the Gateway and docked, and umbilicals between the two modules that are coming together will carry all the power, data, and in some cases, fluid interfaces necessary for the Gateway to be functional. So we don't plan to have any EVAs required, which really does reduce a lot of risk. When you're doing EVA on low Earth orbit, there's always a risk that something might happen, but luckily you're only a few hours from home. If there's an emergency on the station, you have to get home. But out by the moon, 250,000 miles away, it's just too far to affect anything like that. So the plan for assembling the Gateway through non-EVA means really reduces quite a bit of risk.
And my understanding is when Gateway is launched, it's going to be in, and I'll let you explain this, it's going to be in two main modules, right? It's not going to be something that's going to be pieced together with a lot of different parts. It's going to be two main modules that are going to be launched when Gateway is put into place. How is that going to be assembled? Is that going to be done in Earth orbit and lunar orbit? Just explain a little bit the process of how that's going to work.
Sure. So we're going to launch the very first elements of Gateway together. The power and propulsion element is a commercial spacecraft bus. Think of a satellite that's been converted for use as a core propulsion center for the Gateway. It's got the solar arrays and the propulsion system provide all the power and the get up and go for the Gateway to go where it needs to go around the moon and to maintain its own orbit around the moon. The second element that's going to fly with the PPE is called the Habitation and Logistics Outpost. It's the HALO module is an early habitation module that provides limited environmental control and volume for staging the early lunar sorties. It also has 3 docking ports on it. Our logistics modules are going to carry up supplies and carry away the trash, and there'll be also an international habitat that's provided by the European Space Agency that'll carry more docking ports. It'll have even more systems in it to enable longer duration missions. And then after that, we'll be bringing up an airlock to enable external maintenance, like I talked about before. And there will also be an additional module that come a little bit later that'll dock and will refuel the PPE through the HALO ports. That'll be really cool. Lastly, but not least, will be a robotic arm from the Canadian Space Agency that's going to be available so that if we ever need to bring up any replacement parts or bring up any external payloads for science or something on logistics modules, the external arm is going to do the same thing it does on the ISS today. It'll extract payloads and cargo from the logistics vehicles and then place them wherever they need to go on the Gateway. And if there's something on the Gateway that's failed and needs to be disposed of, it'll be able to place things on logistics vehicles, and logistics vehicles will take care of the disposal of that.
And when the supply missions begin, are those going to be crewed flights mostly, or are they going to be autonomous, or is that still kind of to be decided?
The logistics flights are kind of a mixture of autonomy and ground control. So by and large, the vehicle is going to do everything it needs to do to get to the Gateway autonomously. And when it gets to the Gateway, it's going to be able to do its own rendezvous and proximity operations and docking without much involvement from the ground. However, working that far out in space, there's always a need to have the ground systems kind of monitor and make sure that the vehicle is healthy and that it's doing what it's supposed to do. So we expect there's always going to be somebody on the ground kind of keeping an eye on the logistics vehicles. But by and large, it's going to be very much a fully autonomous vehicle like the Dragon vehicles we see today as far as the SpaceX version. We expect any future providers are going to have similar levels of autonomy. But there's always probably going to be somebody on the ground kind of keeping an eye on it. There will be no crew on logistics vehicles. It's a purely cargo vehicle, kind of like we have the Dragon cargo version that flies to ISS today. There's also the Cygnus vehicle that flies, and the up-and-coming Sierra Nevada Dream Chaser. Those are all uncrewed cargo vehicles, but if you look at it, you think, well, you could put a person in that pretty easily, right? Dream Chaser looks like an airplane. I think all of our providers are pretty savvy, and the idea of flying cargo in a vehicle first becomes kind of that stepping stone towards human space flight. So while we don't ever expect to fly people on the logistics services contracts, the systems they're using and they're building to fly the logistics flights can always be stepping stones and the basis for future human spaceflight vehicles if they're designed right from the ground up. But no humans on the logistics vehicles.
And I guess one advantage there is you don't need life support systems if there's no life to support on there. So that may create more room for payload.
Right. That's really the driving idea behind how we approached our contract, and how Gateway kind of sees us as an augmentation of the Gateway, but we're not central to the Gateway's life support system. Certainly, if we expect the crew to be spending a lot of time in the logistics module, we need to make sure that it's well lit, well ventilated, that we've got filters to help filter out any particulates in the air that are generated by the packing and unpacking process. And humans are dirty in general, so the more filtration you can have in a spacecraft, the better. But really, there's not much else in the logistics module as far as supporting crew. They're just kind of making sure that they're comfortable in there. But removing carbon dioxide and humidity will be the job of the rest of the Gateway elements.
And when the autonomous vehicle docks, there's a process for being able to get that cargo onto the platform, right?
Yep. In the early days, it's going to be the crew. We have the concept that's a little bit different for the logistics for Gateway than it is for ISS, in that ISS, like you said before, Keith, it's big enough. You have plenty of room to store things. So when the cargo vehicles arrive at ISS, generally they're unpacked. Everything's brought out and put where it needs to go within the space station. And then at the same time, depending on the mission cadence, the crew will start packing it full of trash for its return flight back to Earth. Our concept of operations for Gateway is a little bit different in that we perceive the Gateway logistics modules as more of a pantry where the crew will go in, retrieve what they need, and maybe bring stuff back and stow it for future use, or that they only unpack things on an as-needed basis because Gateway is just too small, and the logistics that we're bringing up is going to be quite a bit. We're bringing up at least 3,400 kilograms of mass every flight, and we don't expect to be able to offload all of that mass directly into the Gateway. So the modules we fly to the Gateway have to be a little more accommodating, a little more arranged, so that the crew can come and go pretty efficiently. And that pantry concept is something we keep talking about, since we know we have to kind of change people's understanding of how this module can be used. It affects the design a little bit when you know that the crew is going to be interacting with the module quite a bit and spending a lot more time in there. So like we talked about before, efficiency of packing, having an efficient and ergonomic layout is going to be much more important than just bringing up a truck full of stuff that's going to be dropped off and then the truck leaves.
As an engineer, you have the power to impact and shape the future of the world. But we know how hard it is to balance life's responsibilities with getting the education necessary to advance your career and make that impact. The engineering programs offered through LSU Online make it easy to learn at a pace and schedule that's convenient for you. Their programs are 100% online, specifically designed to be flexible for working professionals. LSU Online offers multiple engineering degrees and certificates with focuses in industrial, civil, healthcare, petroleum, and transportation. U.S. News ranks LSU Online as one of the best online programs for a master's in engineering, and with flat rate tuition offered to students nationwide, LSU Online's engineering programs are also some of the most affordable programs available. Accelerate your career growth and leave a lasting impact on the world with LSU Online. Get started by visiting online.lsu.edu/podcast to learn more and receive a code to waive the application fee.
Another unique aspect of Gateway, once it's in place, it's going to have a unique orbit around the moon as well. That's right. It's not going to be a regular concentric orbit. Explain that and the purpose of the orbit that's planned as Gateway remains around the moon.
Sure. Yeah. And I got to tell you, since joining this project, I have learned so much about the different types of orbits that are possible around the moon. Going from being a low Earth orbit human spaceflight guy, where things just kind of go around in circles and everything's 17,500 miles an hour and it's 250 miles up. This has been a change in perspective for sure. So Gateway is going to fly in what's called an NRHO, or near rectilinear halo orbit. So this is an elongated loop of an orbit oriented north and south around the moon's poles. And if you think about it, it's kind of like a long necklace, a very long necklace that's suspended from the moon. Okay, it comes very close to the moon. At its closest approach, it'd be about 3,000 kilometers from the moon's surface. But at its farthest, it'd be about 70,000 kilometers. So it's quite a long elliptical orbit. The time it takes to go through this entire orbit is 6 to 7 days, depending on the parameters of the orbit. But it's got a constant line of sight with Earth, so calm is always good. There's almost no solar eclipse time. I think maybe an hour generally every couple of orbits of eclipse of the sun by the moon. It's extremely stable too, so it doesn't take a lot of fuel to stay there. And it allows access to the entire lunar surface, including the lunar south pole, which is where we're most interested, because we know there's water ice there, and there's areas there that are always in shade or always in sunlight. And the shade helps protect our astronauts from solar radiation. But the areas of constant sunlight are great for solar power. If you want to have a permanent habitat or a permanent base, you don't have to worry about shadows or anything. The NRHO is a great, very unique type of orbit that really just enables all kinds of lunar exploration.
And now, explain a little bit the timetable too, because Artemis is the first Artemis mission is scheduled for late 2021, depending on how the schedule plays out. When is Gateway going to be launched? Because some of the Artemis missions are going to be well underway by the time Gateway is going to be in place. Is that correct? Give me a little bit of the idea of the timetable there.
Right. So NASA is currently planning to launch the PPE and the HALO modules together on a Falcon Heavy in November 2024. So that will support an Artemis 4 mission. This is tough because this is an area of constant change. I'll be honest with you. There's a lot of change in the agency now, trying to align the schedules of the SLS, the Orion, and the Gateway Assembly, while still trying to make sure that the HLS system is also available. So all these systems can come together and execute the Artemis lunar mission. So there's still some planning. Artemis 3 is likely to be its own mission with HLS. It's the way things are looking at this point. Because of the way that the HALO and the PPE, even when they launch in 2024, they have a long spiral that they have to go, a long spiral trajectory because of the low thrust of the PPE. Even under constant thrust, the solar electric propulsion is going to take a long time to spiral the PPE and HALO stack out to the moon. We always intended to take about a year or so for PPE to go to the moon, but it was this recent change of adding HALO to it and putting them together on one launch. That means now there's extra mass, and it's going to take a little bit even longer to go. So the alignment of the program is a little bit hazy at the moment, since so many things have to come together to make the Artemis missions work. But there's so many options available too. You can do the Lunar Direct, which is where you send Orion and HLS directly to the moon, and they can link together. The crew can transfer from Orion to the HLS system and do their lunar mission. So maybe 2 crew go to the surface while 2 crew remain in the Orion. And there's also another mission concept where Orion, this is the Gateway primary mission concept, where Orion would fly to the Gateway. And the thing with Orion flying on SLS, there's a lot of extra SLS performance. So some of the Gateway modules, if they weigh less than, say, 10,000 kilograms, I think is where SLS is at right now, for a co-manifested payload, you can put a payload underneath the Orion on top of the SLS, throw them both into orbit with the SLS. The Orion can extract the Gateway module, just like Apollo did when the Apollo CSM grabbed the Apollo lunar module. And then together, the Orion and the Gateway module could fly out to Gateway, take about 4 days to get there. I think it's about 4 days, maybe 3. And then Orion would dock that module to the Gateway, and now you've just expanded the Gateway, and you started your first or second or third, whichever one it may be, crewed mission to the Gateway. So
like hitching a trailer on the back, right?
It's a little bit like hitching a trailer, yeah. So if all 3 programs can align, if Gateway schedules and Orion schedules and HLS schedules can stay in sync with each other, then we can execute different variants of the Artemis mission. So if Orion goes to Gateway, HLS goes to Gateway, we'll send logistics to the Gateway to meet them both there, and everybody can depart from the Gateway down to the moon. Those sorts of missions are probably going to start around 2027, give or take, where you have everybody playing in low lunar orbit or in an NRHO orbit around the moon together, and we've got the full-on Gateway and HLS and Orion systems coming together to make an Artemis mission happen.
And anyone who knows the history of the space program going all the way back to Mercury, Gemini, and Apollo, mission schedules are always changeable. And a lot of times that's based on what happens in the missions just before. If it's a certain mission or test goes well, everything's on schedule. If not, there have to be adjustments made. So the schedule is always going to be in flux based on what else happens, correct?
Right. And it's going to take a lot of project management chops to make sure that we keep our schedules in sync with each other, right? So there's going to be a lot of cross-program organization. If your audience understands how NASA works, we have programs that are really independent entities. They've got their own budget, their own schedules, their own management architectures. But we always have to have cross-program conversations to make sure that when 2 programs, or in this case 3 programs or 4 programs, because there's the Exploration Ground Systems program happening at KSC that's also part of all of this scheme as well. It's not just the flight systems that have to come into play. Mm-hmm. We've got to keep our schedules in line and make sure that the management teams are working together. And we're lucky, I think, that the architectures we've got to work with, since they're so multifaceted, we've got such a blend of commercial and government. We've got government systems and commercial systems coming into the fold, that there's a lot of opportunity to be flexible. And I think that's why we see the agency kind of weighing its options by shuffling things around and saying, well, if this happens on time, we can actually do this. Or if we get this budget in this budgeting cycle from Congress, then that'll give us the money to do the thing we always wanted to do. But our fallback position might be a backup plan that leverages fewer components, but we can still execute a limited scope mission, right? So we're going to see this kind of settle down as the uncertainty in the budget and the schedules of the different projects and programs that are working on all these systems start to as the uncertainty starts to kind of go down. We'll see the plans for lunar exploration really firm up. And HLS is a big part of that too. They just started. They've got a lot of work to do to get the SpaceX Starship concepts up and flying, and you can see progress almost every week in Boca Chica. So I'm really encouraged that the HLS system is going to be there for us.
And you touched on earlier as part of the engineering team, there are space agencies from other countries, in addition, partnering with the U.S. In this case. And that's been the case with the IISS in recent years, but not as much in the old days of space exploration to the moon. How is that working? What sort of roles are the different countries' engineers and space agencies playing? And it's got to be very important to have a lot of seamless cooperation as well, I would think, because you mentioned all the different elements that are involved, and that also includes the international agencies.
That's true. This is the first program and project I've been involved in where I've seen such close collaboration between the international partners and NASA. I hadn't had many opportunities to see how the technical discussions happen at really high levels. At the moment, we're working with several international partners. We've got the European Space Agency, who in 2020 signed an agreement with NASA to contribute the international habitat, which is going to be not the heart of Gateway, but it's like the hearth of Gateway, right? It's where the crew's going to spend a majority of their time. It's where they're going to have their meals. The sleep stations will be there. They may have a toilet. That's going to be the thing that makes Gateway feel more like a place they can live and work. So that's a crucial element of the Gateway, and that's coming from the European Space Agency. In addition to the IHAB, ESA is also signed on to provide the refueler module that not in the early build-up sequence, but sometime later, the Esprit RM, don't ask me what Esprit is short for, but it is an acronym. The Esprit RM is going to be a module that comes and docks to the Gateway radially. It could be carried up there by an Orion flight on an SLS, and that'll refuel the PPE xenon and monomethyl hydrazine and nitrogen tetroxide systems on the PPE, so that the Gateway can continue to operate in NRHO orbit, or even do other types of orbit demonstrations later on in the Gateway life cycle. The Gateway is a 15-year program at the moment, so we can't make 15 years if we don't get refueled at some point. So that's another critical feature that an international partner is providing. And then, not to forget the Canadian Space Agency, who I talked about before. There's going to be a robotic arm on the Gateway. CSA is going to give us another excellent external robotics system with all kinds of neat tools and end effectors. I can't get over how flexible these systems are and how clever the interfaces are to enable the arm to walk itself around like an inchworm, pick up different tools and use different tools to do different things, to deploy satellites, to berth different modules. If we want to relocate one module from a port to another port, the arm will have that capability. It'll be able to capture free flyers. All kinds of neat stuff enabled by that.
Yeah.
And then last but not least would be JAXA, the Japanese Aerospace Exploration Agency. They're providing all kinds of systems for the IHAB, and they're also tentatively hoping to be able to fly some logistics flights to the Gateway as well. So JAXA has the HTV that they currently fly to the space station, and they're working on a variant of that they hope to fly to the space station and then extend it to be able to fly out to the Gateway as well. So we have a lot of great international partners. We may not even be done yet. We have another module that doesn't really have a contractor or a partner providing it yet, the airlock. And I think we're working to see if there's international partners who are interested in partnering with NASA to maybe supply the airlock as well.
Well, it's great having all that extra expertise for something this complex. The more you read about this mission, the more you realize all the different moving parts that are involved. And as we noted, we may be, as we speak, just a few months away from the first Artemis launch, depending on how the schedule goes. It's got to seem really beginning to be real to you. I mean, a lot of this has been in the planning stages for several years. And when you get close to launch, there's got to be a sense of excitement down there. We saw this in the old days of the space program and space exploration down at the Cape. Is there a little bit of that kind of old feeling coming back at Kennedy that we're going back to the moon and that it's starting to get close and get really exciting down there?
Oh yeah. Yeah. I really hope that I get a chance to get to the Space Center and get into the VAB before the SLS rolls out to the pad and flies. Might not, because the COVID is keeping a lot of us home. So I'm seeing as many pictures as I can from friends who work there and from the NASA media team. But yeah, excitement is definitely high with the arrival of the core stage, the stacking of the core stage, the stacking of the stage adapters, and then the Orion on top of it, and the second stage, the ICPS interim cryogenic propulsion stage. A lot of acronyms to remember. But I was on a meeting where Bob Cabana called in just to kind of give a morale boost to the team, and he mentioned that he was out there and he was just remarking at how unbelievably tall the SLS is. And it made me remember when I used to be able to stand at the pad on the deck of the MLP and look up at the space shuttle stack and just be in awe that something that big could ever fly, much less get into orbit. I mean, you're looking at something the size of buildings. So just this, for me, it's the enormity of the things we do at the Space Center, the scale of the things. It always blows my mind. And I'm really looking forward to seeing the SLS at the launch pad. And I can't imagine what it's going to be like to see a new vehicle fly from those launch pads again. It was amazing enough to see the Falcon Heavy fly from some of the launch pads I used to work on, but to see another NASA vehicle fly is going to be pretty amazing, pretty special. And it means that we'll be one step closer to getting the Gateway fully outfitted and assembled, and to getting crew flying out there and doing some work around the moon. It's going to be a good time to be in space.
Absolutely. And for people who love to watch it, it's a little bit reminiscent of the old days when Apollo was in the Saturn V. Anyone who's been to Huntsville Space Center and seen the Saturn V rocket and the enormity of that, when we first went to the moon, it seems to be like the new generation of that. It's big rockets and complicated systems and a lot of excitement and a lot of engineering. And I think we're all really looking forward to it. We certainly hope the public can get involved in it the way they did back then. It was quite a time. Sean, thanks so much. Anything else about the Artemis mission that you want people to know as we get close to it?
Well, following everything on social media is a great way to show your enthusiasm and to show the NASA team. NASA definitely tries really hard to follow and to have a social media presence, and they pay attention when you're clicking their links and following their posts. So if you're really engaged with the Artemis program and you want to learn more about it, I really encourage you to get on your social media platform, whether it's Twitter, Facebook, Instagram, NASA's everywhere, and follow the NASA programs that interest you. There's hyperlinks out there. There's new hashtags. Gateway just stood up a few new social media accounts that maybe you can post in your podcast notes for your audience. I'll help you get those. But stay engaged with it. There's always something happening with all the different systems and all the different contractors and teams working across the country. It seems like something new is happening every week. So yeah, there's plenty of stuff to go around if you're into space, and if you're a space geek and you like NASA and you like seeing where things are going, get out there and follow, and your news feed will just blow up with all the space stuff that's happening.
Well, I know I am, and I know a lot of our members are too, because they're fascinated with the engineering of this. So it's a very exciting time. We really look forward to seeing Artemis launch and Gateway in action when it comes online. Sean, thanks so much for your time and for giving us that overview. We really look forward to seeing this mission unfold, and we wish you and the whole team at NASA the best of luck. We'll be riding with everyone. We thank you. I also want to thank our IISE space expert, Dr. Barrett Caldwell of Purdue University, who gave us some input in selecting topics for our discussion today. Sean, thank you again, and we thank everyone for listening.
Thanks, Keith. It's been a lot of fun.
Thanks for listening to this episode of Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Metro Atlanta. This podcast is produced by David Brandt, Keith Albertson, and Michael Hughes, and edited by David Brandt. You can listen to all episodes of Problem Solved and learn about sponsorship opportunities by visiting our website, podcast.iise.org. You can also learn more about IISE at the Institute's website, www.iise.org.